ISO Server Firewalls Part 1, Server Security and Firewall Design. In this CBT Nugget, we're going to focus on three major areas. The first of those is going to be the security practices that we use to make sure that the foundation operating system of Windows 2000 or Windows 2003 is locked down. Because if that side of the server is not secure, then ISO Server is not going to be secure. And thankfully, Microsoft makes it very easy for us to do that. The next area is going to be a few of the firewall design strategies that Microsoft gives us, as in, are we going to allow outside access? And if so, how? And are we going to allow people to access our inside servers? And if so, how do we give that access without compromising any of the other systems? We'll look at all of those design strategies. Finally, there's a key concept in ISO Server, and it is the difference between IP routing and packet filtering. There's a lot of confusion in a lot of the people that I've talked to between these two, and when I first saw them, I was really confused between those two things. There are two distinct strategies that you can use with ISO Server to ensure that we allow outside or inside access and we allow it safely. More on that when we get there. For now, let's start off with the security practices. So here are 6 of the best practices that you can use when you're securing your ISO Server operating system. Now, the first thing that you can do is you can think like a hacker. Put on the face of an outsider and think, what would I do to try and break inside of my network? And then go ahead and try it. See if you could do it. Now, if you don't have much experience as a hacker, which I hope you don't, many people go outside and they hire somebody called an ethical hacker. These are people who now work for the side of the good, and they will attempt to break into your network, and then if they can, they will generate a report showing all the areas that you have security flaws in your network. And then you can patch those areas. That's the second major thing. Make sure you patch everything that you find. Not only reports generated by an ethical hacker, but also the auto updates. You know, the ones that download for Microsoft Windows and they pop up and say, you have a new update. A lot of times, those are security holes that are being patched inside of your operating system. Many times, in the example of ISO Server, you'll need to download a service pack or a feature pack that will add extra security to your network. That is one of the essential things day to day that you can do to keep your system up to date from new attacks. Now, number 3 is to stop all the non-essential services that are running on your operating system. Think about Windows 2000 when you install it. There's all kinds of things running. You might have web services and Internet Information Server, FTP services. You might even have email services, DHCP services, all these different services that are running. By going through that Windows 2000 control panel of services and stopping the ones you do not need, you gain 2 things. One is speed. Each one of those services eat up essential memory and processor resources that could be used for other things. So you gain those back as you stop those services from starting. Number 2 is security. Each one of those services presents a potential security hole inside of your operating system. So by stopping them, you completely close the door on those services. Maybe there's a hacking attempt that people know that they can get in through the DHCP server service. Well, by stopping the service, they can no longer even attempt that hacking attempt. Now, to make sure that you have security in your network, you need to turn on auditing. And we're going to talk about this a couple nuggets away. You're going to go in and turn on ISO Server and Windows 2000 auditing, and then it will generate log files of all the potential hacking attempts that are out there. You need to also review those log files. I think of myself. I am the worst at doing this. I will turn on auditing and then come back a month later and find out my log file is 15 megs in size. And I go, oh, open it up, and I see pages and pages of just entries, permits, and denies of people trying to get into the network. And after a couple of pages of it, I usually just clear it and start over again thinking I'll do better next time. Well, by doing that, I'm completely missing hacking attempts that could be going on inside of my network. So you need to set it up on a weekly basis, a regular schedule of reviewing those log files and making sure that you know what's going on in your network. Number 5 is to document your network. Script out on paper or in Visio or some other area what kind of network you have, IP addresses, connections, everything included. That helps you when you see a hacking attempt going on for IP address 10.1.1.1. You go, yes, I know exactly where that's at, and I see what servers are behind it. I see what they're trying to get at, and you can increase your security based on that. It also helps other network administrators that you might have come into your network so that they know what's going on in that network. Finally, you need to make sure that you have physical security of the ISA server. I know. When you see the ISA server and find out that it's running on Windows 2000 or Windows 2003, you might think, oh, well, I can use that for Office or as an Exchange server or a web server at the same time. And yes, you can, but every single time you add something like that to the server, you're introducing another service that could present a security hole. And ISA server is meant to be the strongest security wall inside of your network. So keeping that thing behind lock and key and trying to have a dedicated computer. I know sometimes there's the budget constraints and you can't get around it. But if you can, try and keep that as a dedicated system that only runs ISA server. Now I mentioned at the beginning of this nugget that Microsoft makes it very easy for you to secure your ISA server operating system. And they do this through a system of what's called security templates. These are scripts that are written by Microsoft to secure all the major areas of your operating system. Because regardless of how many services you stop, there's still little knickknacks here and there that Microsoft knows about that we may not. So they've written these INF files, which are templates, that can secure our ISA server in 3 major configurations: dedicated, limited services, and secure. What this is for all the major ways that we can run ISA server. For example, we have 2 major columns. One is the standalone server. This is a server that is not acting as a domain controller, and of course the domain controller side is exactly that, a server that is running as a domain controller inside of your Windows 2000 or 2003 domain. Now there are INF scripts that you can apply for each one of these. For instance, the dedicated level means that we're running ISA server as a dedicated firewall. There is nothing else running on that server. It's not being shared for any other service. All it is just a dedicated firewall. If that is the case, we can apply this HiSec WS for the dedicated servers and the HiSec DC for the domain controllers to secure all the major areas. Limited service means that we are running ISA server as a firewall and what's called a cache server, where it's actually storing those web pages locally on our ISA server system. If we're running that, that is when we apply the limited services templates, again, secure WS for the servers and secure DC for the domain controllers. The final one is the least secure configuration that we could have, and this is when we're using ISA server as a multifunction machine. It is actually being shared as maybe an email server as well, and an SMTP server or a web server. In that case, we can apply this basic SV or the basic DC template, and that will secure it as much as it can, but it's not the most secure template that you can apply. This note is a big one. Once you apply these templates, you can't go back. There's no redo or undo template that we can apply to this. Once you apply it, the only way to go back is to restore it from a backup, or look at the thousands of changes that this template makes and readjust each one manually back to the original setting. Either one of those options I wouldn't want to do. So make sure you know what you're doing before you apply these templates. Once you're ready to apply them, it's very easy. Let me show you what that looks like. To apply the security template, we need to come back to our ISA management console. So go ahead and expand that and go into the servers and array category. There's our ISA server. I'll expand that out, and here is the computer folder. This will show all of the ISA servers installed into the array. As of right now, we only have one. I'll right-click on that and choose the Secure menu option. Like most things, it's going to bring up this security wizard and walk us through it. It only asks one question. Do you want to use the dedicated template, the limited services, or the secure? Now, wait a sec, you might say. I thought there was 6 of them, 3 of them for the dedicated standalone servers, and then 3 of them for the domain controllers. Well, there actually is, but IsoServer is smart enough that behind the scenes it sees what configuration you're running, whether it's a domain controller or a standalone server. So in this case, we're going to use this IsoServer as a cache and firewall, so I'm going to choose the limited services category and click Next. What it's going to do is take me to the congratulations screen. I didn't do much, but it's congratulating me because I'm about to apply the limited services security level template. Now remember, you can't go back once you do this, so be sure. I'll click on Finish. It will bring up this configuration window, and that'll probably take about 5 to 10 minutes depending on what kind of server you have running behind the scenes. So while that's running, let's talk about the next topic, and we'll come back to see what this looks like when it finishes. Okay, now that our foundation server is secure, let's take a look at some of Microsoft's firewall design strategies. The first of them is called the Simple Firewall Design. And in this one, we'll have 2 network cards installed in the IsoServer, one attached to the internet, and the other attached to our internal network. Now the big advantage that you get with this design is just in its simplicity. You only have 2 networks to worry about. In this case, I'll go ahead and throw an Exchange server on our internal network, maybe a PC. Now, this entire internal network will be included in the LAT, the local address table. Now, you remember from the earlier nugget, that's all the addresses that we want to protect from the outside. In this case, I'll go ahead and put the 10 network on this internal network with an 8-bit subnet mask. Now, the disadvantage of this design is that it's not the most secure configuration that you could use. Watch this. I need to poke a hole in this firewall to allow some access from the outside network to the inside so that people can reach this Exchange server. And at a minimum, I'll need to allow TCP port 25. That is the SMTP protocol, Simple Mail Transport Protocol. Now, overall, we are allowing access from our outside network to our inside network at all times. And that's kind of the disadvantage there, because if we have any misconfiguration, at a minimum, people would be able to access other devices on port 25, like that PC. Now, the problem with that is that they could put malicious code inside of those port 25 packets. And if this PC is accepting requests on port 25, they could easily crash it. In the worst case scenario, we could misconfigure it and allow people to access our entire internal network on any port. Now that's a pretty drastic misconfiguration, but that's one of the disadvantages that you run using this simple design. There's a very easy way to make this much more secure. Let's look at that one next. A quick way to make this simple firewall design much more secure is to add a network card to your IsoServer and set it up with a 3-home perimeter design. What this looks like is very similar to the simple design. We still have one network card attached to the external network, which is the internet, and we still have one network card attached to this internal network over here that is included in our LAT. And on this connection, we still have our internal PCs, and now the servers that we have inside of here are only the ultra-secure servers, like maybe a SQL server containing all the accounting information for our company. The third network card attaches to a new network, and this network is called the DMZ. That stands for Demilitarized Zone. All the servers that we want to be accessible from the internet will go inside of here, like that Exchange server we were just talking about in the last slide, and maybe a web server. We'll have Internet Information Server up here. The advantage that we get is when we have to open the ports. For example, this time I'll open TCP port 80 to allow HTTP traffic to come into my web server. I'm only allowing it to pass from the outside network into my DMZ. I will never allow direct access from the internet to my internal network. That won't happen. I won't open any port numbers. What that causes is only the servers in this DMZ have even the potential to be accessed from the outside. This internal network is kept completely inaccessible and completely secure from this outside network. So we can increase our security in a huge way just by sticking in another network card into this. The only disadvantage, if there is one, to this design is it is a little more complex to understand, as in what addresses go in what tables and how we configure this routing. But don't worry, I'm going to come back to this design in just a few because Microsoft gives special attention to it in all their documentation because it's their preferred design. So we'll come back to this and talk all about the address configuration in the different tables. But let me show you this last strategy first. The final of the firewall design strategies is called the back-to-back perimeter design. The reason why is we still have the ISO server on the left connected to the external network. But now we've added a second ISO server in this configuration. Between these two servers resides now our DMZ. And in between these, we put all the servers that require outside access, or I should be saying accessed from the outside, like our Exchange server and the web server. Behind the second ISA server, we have our internal network. And off of this, we have all our PCs and ultra-secure servers that we'd like to protect. Now, the reason this one is a little bit better than the 3-home design is because we've added 2 server redundancies. See, in the 3-home design and also in the simple firewall design, if a single ISA server is compromised, they could potentially have access to everything because they could gain full control of this ISO server and then open whatever ports they'd like to. But in this case, if we lose the first firewall and it's compromised, they still have to make it through a second one. Now, a common question that comes up is saying, well, if they compromise this one, what would keep them from compromising this one? Good question. Overall, this ISA server that is connected to the internet must be made a little weaker because it's allowing access from the internet to all the hosts inside. Any host on the internet can use port 80 to access the web server, and any host on the internet could use port 25 to access the Exchange server. Let's imagine that one of those port numbers was used to compromise the ISA server itself. At that point, they now have to make it through the second one. The second one is not allowing anybody to access it from the internet directly. It has to be coming from maybe this Exchange server. Maybe it's allowing this Exchange server to deliver mail to the internal clients. What that means is that the person who compromised this ISO server must then take over the Exchange server, assume its identity to even have a chance at making it into this internal network. Now, hopefully, by the time that happens, you've figured out that something has gone wrong, and you can put up all the defenses and bring this ISA server back online with a new enhanced security. Essentially, it gives you more time. Given enough time, anybody could eventually break in through any network, but hopefully they don't have that kind of time because you're watching your audit logs and making sure that they don't have that access. The disadvantage of the back-to-back design is, of course, the almighty $sign. Buying 2 ISO servers can get pricey because now it's double the hardware and double the software. Before we continue on with the firewall design, I noticed that the security template just finished applying to the ISO server. So I'm going to go ahead and minimize this and show you how to find out what changes it applied. Notice I have typed into this run prompt the directory that I installed ISO server into. So I'll open it up. And I'm looking for a certain file in this directory called securewiz.log. There it is. Look at the size of that file, 406 kilobytes. Every single one of those bytes are a change that happened to my server. So I open this up, and what I'm able to see is all the user rights, all the group memberships, all the changes that were made by that security template. So you can scroll through this log file if you're curious to figure out what exactly it did, and it will tell you every change that it made. Now let's go ahead and continue on with our firewall design strategies and look at the 3-tiered parameter design and how we make it work. The first thing you need to do in a 3-home perimeter design is configure the 3 network interface cards on the ISA server with the proper IP addresses. Let me show you how the addresses are configured on this ISA server. I'm going to go to a command prompt, open it up, and do an IP config. What I see is that there are 3 network interface cards: the internal, external, and DMZ connection. I would really recommend, by the way, that you label your interfaces using the Windows 2000 Network Control Panel so you know exactly what network they're connected to. Makes it very easy. Notice that the internal network has the private address range, 192.168.0. These are the ones that will be translated using network address translation to the external network, and that I do not want anyone to have access to from the outside. The external interface is given an address from the Internet pool. This is a valid Internet address, and this is the IP address of my Internet Service Provider's gateway. So this is how I'm getting on the Internet. The final one is the DMZ connection, and notice that these are Internet valid addresses too, 150.15.x.y. These are the addresses that are routable on the Internet, that I have purchased from the Internet, that I can assign to all my internal servers on that DMZ. I also want you to see that each one of these interfaces do not have a default gateway except for the external connection. One of the things that I see most often in the field is people have typed in for the default gateway the address of this external connection. They're actually pointing the internal interfaces to the outside one. Well, it may sound really logical. That doesn't work. You need to make sure that this doesn't have any default gateway configuration. The ISA server is smart enough to figure out how this interface and how this network gets to the outside on its own. Now that we've seen how the IP addresses are configured, let me show you how we set up the 3-home perimeter design in ISA server. The private network, or the internal LAN, is still going to be added to the local address table. These were the addresses that started with the 192.168.0 when I did that IP config a minute ago. Now the DMZ, the addresses that started with 150, these will not be in the LAT. This is one of the biggest mistakes I've seen people make when they're configuring ISA server in this configuration. They'll think, oh, well, I have my internal, which is the private, and the DMZ, right? No. Only the internal network is included in the LAT. The DMZ is not in the LAT. As a matter of fact, this introduces a brand new concept that we're going to be looking at. The DMZ uses a system of IP routing. There is literally a checkbox configuration in the ISA server, and I'll show this to you in a moment, that you check to say enable IP routing to that DMZ network. Now there's also something we'll want to add to that. It's literally, again, another checkbox, and it is called packet filtering. What this allows us to do is filter what packets are allowed between these two networks. We will want to enable both IP routing and packet filtering from the Internet to the DMZ. If we just enable IP routing, everything is allowed in here. If we just enable packet filtering, nothing will be allowed in here. There's no IP routing between the two. So overall, these two are combined. These two checkboxes in the configuration are combined to grant access, and only certain access, from the Internet to the DMZ. So let's dive a little deeper into this IP routing versus packet filtering and when we use each. First thing I need you to understand is that there are 3 ways that we can control network traffic. The first is the web proxy service. The web proxy service only allows us to access the Internet using web browsers on our internal network. As you can see here, I'm going into Internet Explorer and opening the connection settings. This is where we can specify a proxy server, and we need to go to every single computer inside of our internal network and type in the address that they can use to reach the ISA server and what port number they would use to use it. Most people use port 8080, and we'll talk more about the proxy configuration in a little while. The disadvantage of the proxy configuration is it only allows you to access the internet using a web browser. Any other application will not be able to. The second way to control network traffic is through the firewall service using the SecureNet proxy. This is where we have our ISA server connected to our clients on the internal network and connected out to the internet. And our clients can use any TCP or UDP-based application to access the internet. However, they're doing it through the proxy. So the ISA server is the one that is going out to the internet and getting it for them. It's kind of like on Sunday morning when it's really cold outside. I have my dog go out and fetch the paper because I don't really want to go outside because it's too cold, and the dog goes out, grabs the paper, brings it back for me. Same way here, the clients on the internal networks are saying to the ISA server, hey, could you go outside and get this web page or access this application for me? So the ISA server is the one doing the work. This is good because the person on the internet thinks that this IP address, the actual ISA server, is the one accessing the internet. And if any attacks come, they'll come back at this ISA server, not the internal client. The ISA server is the protector of these internal clients using the proxy service. Not so with the routing service. The firewall service using routing is where it's actually forwarding the request and the internal IP address of this client out to the internet. So the ISA server is just acting as an intermediary, kind of passing packets back and forward between these two. There could be some malicious packets passed back and forth with the IP routing, and hopefully we've filtered those down and limited the possibilities using packet filtering. We'll talk about that in just a moment, but these are the three ways that you can control network traffic. Okay, let me describe what packet filtering is all about as it relates to ISA server. I say that because I know a lot of people are probably listening thinking, well, I've heard of packet filtering. That's just allowing and denying packets, right? Well, it is, and that's what it does in ISA server. However, it's implemented a little differently. There is literally a checkbox that you're going to turn on, and I'll show you where that is in just a moment, that says Enable Packet Filtering. Okay? And as soon as you check that box, instantly ISA server denies every single attempt from the outside network to reach anything on your inside network. And you get to specify what is allowed through. Now be careful here, because there is a concept called dynamic packet filtering that helps you out tremendously. For instance, when this internal computer attempts to access the internet's going to have to bring some information back to that computer to satisfy that access attempt. It's kind of like when I let my dog out to get the paper, I recognize my dog coming back with the paper in its mouth, and I open the door for it. In the same way, ISA server is the one letting the packets out. So when they start coming back with the response information, it recognizes them and allows them through. You don't need to statically define any ports for those. What I'm talking about when I say packet filtering and defining what's allowed is things that originate from the outside network, not in response to any request from your internal network, and are attempting to access some resource inside. When you are creating a packet filter, you're going to get two options: to allow or to block packet transmission. Now don't worry, I'm going to show you the complete configuration of a new packet filter in just a moment. I just want to show you some of these options. Now what's interesting is when you turn on packet filtering, I just mentioned before, everything is instantly blocked. So why do they have a separate option here for this block packet transmission? Well, this defines exceptions to the allow packet rule. For example, let's say I allow some packets and I say I'm going to allow some custom traffic, anything that uses TCP on port, we'll say a fixed port of 25. I'm going to allow through. But then I realize after I'm doing a little auditing and monitoring that, somebody is trying to hack my Exchange server on port 25. Well, what I can do then is I can do a block packet transmission to define an exception to the allow rule that I just set up. So packet filtering allows me to define what I want to allow and deny inside of my network. but there is a definite distinction that I want all of you to follow me on. IP routing and packet filtering. These two things are two different configuration items inside of ISA server. I can turn on IP routing and leave packet filtering off, and what that will do is allow full-blown routing to go between whatever networks I define in IP routing, and I'm talking without security. Allow everything that's anything to go through. I could also define that I want to turn packet filtering on and leave IP routing off. Now you might think, well, won't that just deny everything? Careful. Because remember, we have the web proxy service, or I should say the firewall proxy service, that is allowing secure NAT transmissions to go through, and those don't actually require IP routing. But wait a sec, how can that be? Well, remember, the ISA server is the dog. Remember, it's the one going out and doing the work for us. It's not true IP routing because the client is saying, excuse me, ISA, would you go get this information for us? And ISA server goes out and gets it and brings it back. So it's not going to be true IP routing in that case, and packet filtering is blocking everything. So hopefully I've made this distinction for you. IP routing and packet filtering are two separate configuration items inside of ISA server. So now that we know that packet filtering and IP routing are two separate configuration items, I want to show you each one of the four combinations that you can have because it really gives you a good idea of what these two mean and how they affect the ISA server. First off is packet filtering option off and IP routing options off. What this does is it allows your ISA server to answer requests for the client, because remember, it's like the dog going out and getting the paper. It's going to be able to go out to the internet and retrieve things for this client, and the internet's going to be able to come back in, and it's going to have no problem getting information for those clients. However, since packet filtering is off, there is no protection for this ISA server. Anybody from the internet can come on in, a malicious hacker can come on in and attempt to break into the ISA server itself. Now, thankfully, because IP routing is off, the ISA server cannot forward requests to the inside network from the internet. So that's safe, but the ISA server itself could be a victim. So the only way I would use this configuration is if I owned this line. If maybe this was a lease line between ISA server in Canada and ISA server in California. At that point, I know what kind of traffic is going to go between there, and I would feel comfortable turning off packet filtering. Now, why would I do that? Well, it makes it a little faster because the ISA server doesn't have to inspect every packet on the way. Now, how about this combination? Packet filtering on, IP routing off. This is the most common combination if you do not need to provide outside access to your internal network. If you just have the ISA server with clients on the internal network accessing the outside and nothing more, this is all you need because packet filtering will deny any outside attempt to get into the network, and since IP routing is off, there's no way the ISA server is going to ever forward requests to the internal network. So we're protecting ISA server with the on, and we're keeping requests from being forwarded with the off, except for the requests that are coming from these internal clients. Remember, the ISA server is that dog. Packet filtering on, IP routing on. This is the most useful when we have some sort of DMZ configuration. When we have the external network and the ISA server needs to route to some sort of internal server and still has those private clients on that internal network. This is the configuration that most people use to provide the inside access using IP routing and filter it using IP packet filtering so that it keeps those requests exactly to the port numbers you want. This one is not very wise and is actually not really a good idea if you even want to use ISA server. This allows full-blown routing between your network without any packet filtering. If you want to do this configuration, you don't need ISA server. Windows 2000 will do this for you using the routing and remote access control panel by itself. ISA server is the one that adds the packet filtering functionality. So if you want this configuration, save yourself some money and just use the Windows 2000 or Windows 2003 built-in tools. So where have we been in this nugget? Well, we've seen, number one, how to secure the foundation operating system of ISA server using those security templates that Microsoft gives us to lock things down. We then explored the 3 different firewall strategies that are given to us. 1 is the simple design, 2, the 3-tier perimeter design, and 3, the back-to-back, the dual firewall design that helps us secure our network in many different ways. Finally, we hit the key concept of IP routing versus packet filtering, what these 2 options are, when we would use each one, and then when we use both of them together. I hope this has been informative for you, and I'd like to thank you for viewing.